Okay, now these are getting a little bit more harder. So this one says, suppose x and y are related by the given equation and use implicit differentiation to determine dy dx. Okay, so what's the first step? We're going to tell them that we're taking the derivative of both sides with respect to x. As you can see, the right side of the equal sign is automatically 0 because that's derivative of a constant. Now the right side, I'm sorry, not the right side, but the left side, let's separate these. Derivative of x to the 6 times y plus derivative of y to the 6 times x. Now we have to use which rule? The product rule twice. We have to use the product rule twice in this situation. So I'll start with the first. Okay, I'll start with the first. Okay. First times the derivative of the second. First times the derivative of the second, dy dx, plus second times derivative of the first, 6x to the 5th power. Hopefully, by now, we can do some product rule in our head. Otherwise, writing all these down will be very confusing. So, well, it's okay if you still want to have like an organized work on the side. That is completely fine. Now, let me do the next part, okay? First times the derivative of the second plus second times derivative of the first, 6y to the 5th power times dy dx. Okay, and all that equals 0. Okay, now what I'm going to do is I'm going to identify all the terms that has dy dx. I'll circle all the terms that has dy dx. This term has dy dx. This term has dy dx. And the other ones don't have dy dx. So the ones that don't have dy dx, I'll move them to the right side of the equal sign, okay? And what I can do on the left side of the equal sign is I can pull out the dy dx to the front. Let me write down dy dx in front. And just take a look at the ones inside these green circles, okay? In the green circle, the first green circle, I'm going to just write down x to the 6th power now, plus, now the second green circle, if I factor out dy dx, what's left? X times, well, let's go ahead and write the 6 first. 6xy to the 5th power, right? So I'm done with the right side of the equal sign. But hold on, what I will do is I will move these two to the other side of the equal sign because they don't have dy dx. So that will turn into minus 6x to the 5th y minus y to the 6th power. Okay? And all I need to do is divide both sides by this parenthesis. Maybe I'm going to have to make these a little bit smaller. It's so difficult, and I think I'm doing it way too fast. So if you email me about do it again, I will gladly do it again. So we found dy dx. Dy dx is this fraction, negative 6x to the 5th y minus y to the 6th over x squared plus 6xy to the 5th power. And that is how you can implicitly differentiate this very challenging equation. We had to use the product rule twice. I want you to look at each pieces very carefully. I don't think this is an easy problem at all, but if you just look at it very carefully, I am sure that you can handle something like this, okay? All right, let's try one more on this very same page. This time we're not only going to find the derivative, we will use these given point, x of -4 and y of -1 to find the slope of the curve, okay? So let's do implicit differentiation. I'll take the derivative of both sides. The right side of the equal sign is automatically 0 because derivative of a constant is just 0. Let's separate these two terms. Take the derivative of 8x squared subtracted by derivative of 5y to the 3rd power. Okay, all right, we're ready to start. Focus on the first piece. What's that going to give us? That's going to give us 16x. Now, the second term, 5y to the third power. That's going to give us negative, because of this minus sign right here, 15y squared times dy dx using the chain rule, right? Now what I will do is I will subtract 16x from both sides. If I do that, I'll get negative 15y squared times dy dx equals negative 16x. Last step is to divide both sides by negative 15y squared on both sides. If I do that, dy dx comes out to be, they're both negative, let's make it positive 16x over positive y squared. So you found it. So what is the slope going to be? We're going to plug in x equals negative 4 and y equals negative 1. So slope is going to be 16 times negative 4 over 15 times negative 1 squared. So let me just use my calculator for that. 16 times negative 4 and 15 times negative 1 squared is negative 60 over 15. So that is how you can find the slope of the curve at the given point. But you're going to have to first find the derivative implicitly. Okay? I really do think I went too fast. But hey, I want you to email me if you want me to go over these again. I will be happy to do that again for you. Okay? So that's it for the second page. I'm going to come back and go over the third page in another video.